Hi everyone, welcome back from Thanksgiving break. I hope you had a wonderful few days of rest. And if you had any time to get caught up, I hope it was productive. If not, that is okay. I hope it was relaxing for you. We are going to cover Unit 5, Day 3. We're going to cover 3 more shortcuts. The last 3 for proving triangles are congruent. You can find these notes available on OMHS, Unit 5, Day 3. The key is there also. Let's get started. All right, so last class we talked about side, 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 and side, angle, side. Side, 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 we had to prove that all 3 sides of one triangle were congruent to all 3 sides of another triangle. And as soon as we did that, we were allowed to say the triangles were congruent. For side, angle, side, we had to prove that 2 sides were congruent to 2 sides of another triangle, and the included angle was congruent. And as long as that was true, then we were allowed to say the triangles themselves were congruent. Well, today we're going to talk about angle, side, angle. Okay, so angle, side, angle says that you have to have 2 sets of congruent angles. So in this case, we'll say that angle A has to be congruent to angle D. And we can say that angle B has to be congruent to angle E. And then we want the included side. Included side means the side that's touching both of those angles. So we'll say that AB has to be congruent to DE. As long as that is true, then we can say that triangle ABC is congruent to triangle DEF by angle, side, angle. So some examples of that. Oh, I see 2 triangles that are smushed up against each other. Probably a good idea to redraw them. So triangle QRS, triangle QTS. And they have a side that they're sharing, so we're probably going to have to use the reflexive property. But let's start at the beginning. It says the SQ bisects angle RQT and angle RST. So that's given. I see that vocabulary word. And it's saying that SQ is bisecting angle RQT, which means that this angle is being cut in half. So angle RQS and angle TQS have to be congruent. I'm going to mark that in my picture, and that's exactly what the second step is saying here. So this will be the definition of an angle bisector. You're going to see me write bisects, that's okay. But it also says the SQ bisects angle RST, that's over here. So that means these 2 angles have to be congruent. So I'll mark that in my picture. And that's exactly what it's saying here in step 3. So that's the definition of an angle bisector again. Since it bisected 2 angles, probably going to have to use that definition twice. And now QS congruent to QS, well, anything's congruent to itself. That's the reflexive property. We thought that was going to be happening eventually in this problem. And now I have 2 sets of angles that are congruent and the included side. So I can say that these 2 triangles are congruent by angle, side, angle. Let's redraw these triangles. They're up against each other. Do you have to redraw the triangles? No, you don't have to. But if you ask me for help, it's going to be one of the very first things I recommend that you do. I think that it can help make those triangles very obvious as to what's congruent to what. And we'll go here. M, L, K. There we go. All right. I see this parallel stuff going on. As soon as I see parallel lines, JK is parallel to LM. I see a transversal. So I bet we're going to have some alternate interior angles happening. Angle JKL is congruent to angle MLK. That's exactly what I just labeled. So these are alternate interior angles. And I'll mark those in my picture. MLK, there we go. And then it says that angle JK or JLK, oops. Okay, we're back in business. So it says that angle JLK that's here is congruent to MKL. Well, those would be alternate interior angles also, since the top is parallel to the bottom. So we've got alternate interior angles again. If it helps to redraw these pictures a few times so that you can highlight everything that you need to, that's okay. I'll mark that up here in my picture here. And now KL is congruent to KL. Well, that's the reflexive property, of course. And now we've just proven that we have two sets of angles that are congruent and the side in between. So this is angle, side, angle again. Now these two triangles are drawn separately enough for me, but if you want to redraw them, you are welcome to. All right, we've got a blank proof here. That's okay. We'll say angle BAC is congruent to angle DEC. That's given to me. And I'm going to mark that in my picture. BAC, DEC. Then it says C is the midpoint of AE. That's given. And I see that word midpoint, probably going to need its definition. C is the midpoint of AE. So that means that AC and CE are going to have to be congruent. So AC is going to be congruent to EC because that's what a midpoint is. That's the definition of midpoint. And now we need one more thing to prove these are congruent. I see lines crossing each other. When we see lines crossing each other, we should start thinking about vertical angles, right? So we can say that angle BCA is congruent to angle DCE. I have to name these angles with 3 letters since C is part of both triangles. I can't just call them angle C, because if I said angle C, you wouldn't know which triangle I was talking about. So we have to name them with 3 letters. Now I have 2 sets of angles congruent to the other triangle and the side in between. So I'm allowed to say that triangle ABC is congruent to triangle EDC by angle, side, angle. All right, so now there's another shortcut. This shortcut is called angle, angle, side. If 2 angles and a non-included side of one triangle are congruent to 2 angles and a non-included side of another, then those triangles are congruent. So when it says non-included, it means the side that's not in between. Even in the name, see the side is not in between the 2 angles. So if angle A is congruent to angle D, if angle B is congruent to angle E, and a side that's not in between AB or DE, so we could say BC is congruent to EF, then triangle ABC will be congruent to triangle DEF by angle, angle, side. Okay, so the difference, we just learned about angle, side, angle, and now we're learning about angle, angle, side. What's the difference? The one angle, side, angle, that side is between the 2 angles, whereas in this one, the side is not in between the 2 congruent angles. So in this one, I'm going to redraw the triangles since they're right up against each other. I like to redraw them facing the same way. So here we've got a triangle YZX and YZW. The given says that YZ bisects angle WYX. Bisect means cut in half. So YZ is bisecting angle WYX. That's here. So in my picture, that would be here. Okay, and I knew that because that's what bisect means. So I'm going to say that angle ZYW is congruent to angle ZYX because we know the definition of a bisector. Again, I have to use 3 letters to name those angles since angle Y is in both. If I said point to angle Y, you wouldn't know which triangle to point to. So you have to name it with 3 letters. Now I know that angle YWZ is congruent to angle YXZ because that was given to me. So I'll mark that in the picture. YWZ is congruent to YXZ. Miss Grandy, could we switch our steps 2 and 3? Sure, you could. You could have said both givens first and then gone on with the definition of bisector. That's okay. Hopefully, when you looked at this problem and you saw those two triangles smushed up against each other, your brain said, we're going to need the reflexive property. Anytime those triangles share a side, we can say that that side is equal to itself by the reflexive property. We can mark that in our picture. And now I have two angles that are congruent to two angles in the other triangle and a side, but that side is not in between. So I can say that triangle WYZ is congruent to triangle XYZ by angle, angle, side. The side's not in between the two angles. Here in this one, they're separated enough for me, but if you want to redraw them, you may. Angle ABC is congruent to angle CED. That's given, and I'm going to mark it in my picture. ABC congruent to CED. And it says that AB is parallel to CE. I bet we're going to need some angle relationships. Let's just go ahead and put that third given there to get it out of the way. C is the midpoint of AD. Okay, so let's work with that parallel stuff. AB is parallel to CE. Here is a transversal. Okay, well, I see some corresponding angles here. I'm going to say that angle BAC is congruent to angle ECD because of corresponding angles. So this is a little different. We keep saying alternate interior angles with these pictures, but in this one, it was corresponding angles. Okay. And now we need to talk about midpoint. Well, C is the midpoint of AD, which means AC and CD have to be the same length. So AC has to be congruent to CD because that we know that that is what midpoint means. And now I have two triangles with two sets of corresponding congruent angles and a set of sides that are congruent, but that side is not in between the two angles. So we're going to call this angle, angle, side, proving triangle ABC is congruent to triangle CED. Another example. Hopefully, the more examples you see, the easier this is becoming. Hopefully. Ooh, okay, triangles clearly don't have to be perfect. Mine are not. All right, PQR, PSR. All right, the first given says that PR bisects angle QRS. That's given. You now at this point can use what you know about bisector and make that step 2, or you can put the other given and make that step 2. It doesn't matter. I'm going to put that other given there just to get it out of the way, but it doesn't matter. PSR, that's this angle, is congruent to PQR. That was given. Now we're going to use that definition of a bisector. PR is bisecting angle QRS, that's here, which means these two pieces have to be the same size. So angle QRP and angle SRP have to be congruent. So angle QRP is congruent to angle SRP, naming them with 3 letters since most of those letters appear in both triangles. That's the definition of an angle bisector. And we know that anytime that we see it sharing a side, it's going to be congruent to itself. So we can say that PR is congruent to PR. That's the reflexive property. Man, that one comes up a lot, doesn't it? Now I've got 2 angles that are congruent to 2 angles in the other triangle and a non-included side. So I can say that triangle PSR is congruent to triangle PQR by angle, angle, side. Let you try this proof. You've seen me do quite a few of them. Go ahead and try it. Just try. Okay, go ahead and check yours with mine. I will tell you that steps 2, 3, 4, and 5 could have been in a different order. So if you said my step 2, but then your step 5, and then your step 4, and then your step 3, that's fine. None of these really depended on one or the other. So you could have said steps 2, 3, 4, 5 in any of those orders that you see there. As long as your step 1 and step 6 definitely match with mine, steps 2 through 5 could have been in whatever order you thought of it. Okay. There's one more shortcut, and this shortcut we call HL. H stands for hypotenuse and L stands for leg. There's only one kind of triangle that has a hypotenuse, and that is a right triangle. So if you are going to use hypotenuse leg, you must have a right triangle in your picture. Okay, so if the hypotenuses are congruent, so in this case, that would be BC and EF, and one leg is congruent. So in this case, that would be AB and DE. Then you can say that the triangle ABC is congruent to triangle DEF by hypotenuse leg. Just a little recap from when you learned about right triangles back in middle school. Right triangles, their hypotenuse is the longest side, and it's always across from the 90-degree angle. Now, one thing that students do tend to get confused is as soon as they see a right triangle, they think they have to use hypotenuse leg. That's not necessarily true. You could have a right triangle, but use one of the other shortcuts. But if you're going to use hypotenuse leg, you have to have a right triangle. Okay, so just because you have a right triangle doesn't mean you have to use hypotenuse leg. You could use a different shortcut. However, if you're using hypotenuse leg, you do have to have a right triangle. So looking here, I'm going to redraw these two triangles separate from each other. Okay, I've got P, M, and L, and P, M, and N. And it says that triangle P, let me try again, triangle LMP and triangle PMNP, oh my gosh, I know my alphabet, I promise, are right triangles. That's given. So I'm going to go ahead and make them right triangles. Here we go. And then it says that ML is congruent to MN. ML and MN. Oh, those are the hypotenuses. Well, we know that anytime they share a side, that side is congruent to itself. So that's the reflexive property. And that would be a leg in each of the triangles. So now I have a right triangle. I have congruent hypotenuses and I have congruent legs. That's everything I need to prove the triangles are congruent by HL. Example 2. Triangle WVX and triangle YZX are right triangles. That's given. So let's make them right triangles. There we go. And then it says that WV is congruent to YZ. That's given. And we'll mark that in the picture. And then it also says that X is the midpoint of WY. That's given. Well, midpoint means that it's in the middle. So WX and XY would have to be congruent. So we can say that WX is congruent to YX because we know that's the definition of a midpoint. And if you look at your picture, you have right triangles with congruent hypotenuses and congruent legs. So we have everything we need to prove that triangle WVX is congruent to triangle YZX by hypotenuse leg. So far we've seen 5 shortcuts and examples shown to you separately. So when I showed you side, 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 I showed you examples that used side, side, side. When I showed you side, angle, side, you saw examples with side, angle, side, and so forth. Next class, we're going to go over all of these shortcuts, but they're all going to be mixed up, and you're going to have to be able to decide what property is being used. Is it side, side, side? Is it HL? Is it side, angle, side? Is it angle, angle, side? So you're going to have to be able to know that based on the picture. But for today, just make sure that you're reviewing these 3 shortcuts. Next time we'll put them all together. Don't forget to do the attendance quiz and don't forget to do the exit ticket. Come see me in office hours if you need some extra help. I'm happy to help you. Have a wonderful day, everyone.